Hi friends, today we will discuss acceleration concept. Just before discussing the acceleration concept, I want to give one example on average velocity and instantaneous velocity. Okay, let us consider a graph, that is position time graph. Along this direction it is position is along y-axis. I am assuming that position as x. Time interval is along x-axis. Along the x-axis, the time interval is taken as t, two-dimensional coordinate system. Okay, it is origin. Position is in meters. It is in meters, and time is in seconds. Time is in seconds. Now, the graph is in this manner. We will consider the graph in this manner. 0, 1 second, 2 second, 3 second, 4 second, 5 seconds, 6 seconds, and here it is. 2 meters, 4 meters, 6 meters, 8 meters, and it is 10 meters. 2, 4, 6, 8, 10. Now find out the average velocity during the time t is equal to 2 seconds to t is equal to 6 seconds. Our aim is find the average velocity. Average velocity. It is also equal to average speed because the particle is moving along the same straight line. Average velocity during the time interval t is equal to 2 seconds to t is equal to 6 seconds. T is equal to 2 seconds to t is equal to 6 seconds. Now to find out the average velocity, first with respect to this 2 seconds you draw a line in this manner. Now here also with respect to 6 seconds you can drop a line from curve 1 to this point 6 seconds. You can assume it as t1 and it is t2. This point is P and this point is Q. Now you draw a straight line by using these 2 points. You draw a straight line by using those 2 points. Now, with respect to this point P, you can draw a line in this manner. With respect to point Q, another line. What are here? It is x1 and it is x2. x1 is equal to how much? Approximately it is equal to 1 meter. It is 1 meter. And x2 is 7.5 meters. x2 is equal to 7.5 meters. t1, t2 seconds, t1, 2 seconds, t2, 6 seconds. Now what are the coordinates of p? t1 comma x1, coordinates of q, t2 comma x2, t2 comma x2. Now average velocity or average speed. That average velocity V average is equal to slope of this straight line PQ. slope of the line PQ. Slope of the line PQ, which is equal to change in y coordinates, nothing but x2 minus x1 divided by change in x coordinates, t2 minus t1. What is that x2 minus x1 indicates? Final position minus initial position. It indicates displacement. t2 minus t1, time interval. That is, it becomes the average velocity. Now you can substitute the values in this. How much? x2 7.5, x1 1, t2 6, t1 2 seconds. 6.5 divided by 4 meter per second. 6.5 divided by 4 meters per second. That is average velocity or average speed. Okay, next. With respect to this graph, we want to find out instantaneous velocity. What is meant by the instantaneous velocity? The velocity of a particle at a particular instant of time is called instantaneous velocity. That instantaneous velocity we want to calculate. Here, find instantaneous velocity. Instantaneous velocity at t is equal to 4 seconds. At t is equal to 4 seconds, we want to find out the instantaneous velocity. Now you tell me how we find out that instantaneous velocity. Instantaneous velocity, v is equal to, okay, listen to me. To find out that instantaneous velocity at t is equal to 4 seconds, corresponding to t is equal to 4 seconds, corresponding to this t is equal to 4 seconds, you can drop a line from the curve in this manner. Now, at this point, you can draw a tangent. You can draw a tangent at that point corresponding to that time. You can draw the tangent in this manner. I am assuming the tangent as A, B. Now, instantaneous velocity, nothing but slope of the tangent drawn, slope of the tangent drawn at t is equal to 4 seconds. T is equal to 4 seconds. Now we want to find out the slope of this tangent. Okay, what are the coordinates of A? 0. Okay, here, from here to here, the time I want to consider it as 2.3 seconds, comma 0. Y coordinate is 0, x coordinate is 2.3. Now you can drop a line in this manner. Its coordinates are B coordinates are. B coordinates are, what is about this? Approximately 5.8 seconds. Therefore, 5.8 seconds, comma, corresponding to B. Position is 4. 5.8, comma, 4. That is 2.3 seconds, comma, 0 meters. 5.8 seconds, comma, 4 meters. Then, that V is equal to slope of the tangent. change in y coordinates 4 minus 0. Change in y coordinate 4 minus 0 divided by change in x coordinates 5.8 minus 2.3. 4 divided by 3.5. 4 divided by 3.5 meter per second, or 3.5, 7 by 2, 8 by 7 meter per second. That is the instantaneous velocity. What is meant by the instantaneous velocity? The velocity of a particle at a particular instant of time. To calculate that, we are using this concept. Slope of the tangent drawn at that particular instant of time gives instantaneous velocity. Another example. Here also it is a position time graph. Position is taken along y-axis. It is in meters. Time is taken along x-axis. It is in seconds. In seconds. Now, particle is moving along the same straight line. Particle is moving along the same straight line. For that motion, when we plot the graph, it indicates a straight line passing through the origin. The graph indicates a straight line passing through the origin. Okay. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, in this manner. Here it is 2, 4, 6, 8, like that. These are in meters. Okay, just you observe this. What is this time interval? 1 second. During this time interval 1 second, that is in first 1 second, how much distance or how much path length or how much displacement it covers? 2 meters. In next 1 second, second 1 second, how much displacement does it covers? 2 meters. In third 1 second, displacement is 2 meters. That is, here the particle is having equal displacements in equal intervals of time. Equal displacements in equal intervals of time. That's why we can say that that particle is having uniform motion or uniform velocity or uniform speed. That is, here the particle is in uniform motion. Particle is in uniform motion. From the graph, we can say that that particle is in uniform motion. What is meant by the uniform motion? If the particle covers equal displacements in equal intervals of time, then that particle is said to be in uniform motion. If the particle covers equal displacements in equal intervals of time, then the particle is said to be in, uniform motion. Said to be in uniform motion. That is, its velocity is uniform or its velocity is constant. That is, its velocity is constant. Particle is moving with constant velocity. Now, you can find out the average velocity during the time interval t is equal to 1 second to t is equal to 3 seconds. First one, find out the average velocity during t is equal to 1 second to t is equal to 3 seconds. Okay. T is equal to 1 second to t is equal to 3 seconds. How to find out that average velocity? Slope of this line. Slope of that line indicates average velocity. Now, what are the coordinates of this point P? Yes, it is 1 second, 2 meters. What are the coordinates of this point Q? It is 3 seconds, 6 meters. Therefore, average velocity nothing but slope of PQ line. Which is equal to change in y coordinates 6 minus 2 divided by change in x coordinates 3 minus 1. 6 minus 2, 4 divided by 2, which is equal to 2 meter per second. Now you can observe average velocity during the time interval t is equal to 0 seconds to t is equal to 4 seconds. 0 seconds to 4 seconds. Coordinates of this point is 0, 0. Coordinates of this point are 4, 8. Now, what is the slope of this line? 4, change in y coordinates, 8 minus 0 divided by 4 minus 0. It also 2 meters per second. That means slope of this line remains constant because it is a straight line which is passing through the origin. That's why the slope of that line remains constant. It does not changes. That's why we can say that the particle is having constant velocity. If the slope of the line remains constant, then we can say that the particle is having constant velocity or the particle is in uniform motion. Now, find out the instantaneous velocity. That is, at 2 seconds, you can find out the instantaneous velocity. Instantaneous velocity at t is equal to 2 seconds. That is, you want to draw the tangent at this time interval 2 seconds. That is, at this point, we have to draw the tangent. When you draw the tangent, the same straight line occurs to us. Therefore, what is the slope of this? That is, that instantaneous velocity at t is equal to 2 seconds. V becomes how much? Same slope of this tangent. Nothing but slope of this line. What is the slope of this line? 2 meters per second. Which is equal to how much? 2 meters per second. Here, instantaneous velocity. Nothing but slope of this line, nothing but slope of the tangent, its slope is equal to how much? 2 meters per second. Now what is the instantaneous velocity at this point? Same 2 meters per second. Instantaneous velocity at that point, 2 meters per second. Instantaneous velocity at this point, 2 meters per second. That is at this time interval, or at here, or at here, or at here. Instantaneous velocity does not changes. Therefore, the particle is said to be moving with uniform velocity, or the particle is in uniform motion. In this example, it appears that average velocity is equal to instantaneous velocity. Average velocity is equal to instantaneous velocity. That is, if the particle is in uniform motion, average velocity is equal to instantaneous velocity. If the particle is in uniform motion, if the particle is in uniform motion, then its average velocity is equal to instantaneous velocity. Average velocity is equal to instantaneous velocity. Remember that. Now here, what is this graph? A straight line passing through the origin. Now according to the coordinate geometry, a line passing through the origin, that is a straight line passing through the origin, its equation can be represented as y is equal to mx. What is that equation shows? A straight line which is passing through the origin. Y is equal to mx. Now you can compare these quantities with respect to this equation. Instead of y, here we are assumed that position. That is, instead of y, in this example we are assumed it as position. Instead of x, which is exist, time interval, time. Instead of x, it is time. Therefore, this equation can be written as x is equal to some constant m into t. If a line is passing through a straight line is passing through the origin, then its slope remains constant. Here, what is this m indicates? Slope of this straight line. What is the slope of position time graph indicates? Yes, it is velocity. Therefore, what is this m indicates? Velocity. What type of velocity it is? Constant velocity. Instead of m, we are using v. Therefore, x is equal to v into t. What is this v indicates? Constant velocity. That is, if the particle is moving with constant velocity, then its displacement after a time t seconds can be calculated by using the formula x is equal to v into t. What is this x indicates? Displacement of a particle after a time t seconds when the particle is moving with constant velocity v. That is, x is equal to vt. Now I will discuss acceleration concept. Acceleration concept. Acceleration. Average acceleration. A average is equal to change in velocity divided by time interval. Change in velocity divided by time interval. Average acceleration is the ratio of change in velocity to its time interval. Now, what is change in velocity? That change in velocity may be either in magnitude of velocity or in direction of velocity or in both magnitude and direction. This change may be, either in magnitude of velocity or direction of velocity or in both. The change may be either in magnitude of velocity or in direction of velocity or in both magnitude and direction. Remember that. Okay, this is the time interval. It is the change in velocity. In this, velocity is a vector quantity. Therefore, acceleration is also a vector quantity. Acceleration is also a vector quantity. It is a vector quantity. That acceleration is a vector quantity. What is its SI unit? What is the SI unit of velocity? Meter per second. Time interval SI unit, second. Therefore, it becomes meter second power minus 2. Meter second power minus 2. That is meter per second square. This is the SI unit of acceleration. Okay. Here, to discuss this average acceleration, also I want to draw a graph. Let us consider that graph is velocity time graph. Now you can plot the graph in this manner. Along this velocity, which is in meter per second, time interval, it is in seconds. Time interval, it is in seconds. This is the graph. Particle is moving along the same straight line. Its velocity changes with respect to the time. By using those values, when we plot the graph, it gives a curve in this manner. 0, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, so on. Now here, 2 meter per second, 4 meter per second, 6 meter per second, 7 meter per second, 8 meter per second, so on. Now we want to find out the average velocity during the time interval t is equal to 1 second to t is equal to 4 seconds, or t is equal to 0 seconds to t is equal to 4 seconds. We want to find out the average acceleration. Average acceleration. Average acceleration. Average acceleration during t is equal to 0 seconds to t is equal to 4 seconds. During the time interval t is equal to 0 seconds to t is equal to 4 seconds, we want to find out the average acceleration. Now, what is meant by the average acceleration? Yes, it is change in velocity divided by time interval. Okay. Now, 0 seconds. Corresponding to 0 seconds, what is the velocity? 0. Now, corresponding to 4 seconds, what is the velocity? 6 meters per second. Okay. It is taken as P and this point is taken as Q. This point is P, this point is Q. Now, what are the coordinates of this point P? 0, 0. Coordinates of point Q are 4 seconds, 6 meter per second. You can assume it is T1, it is T2. Here it is V1. Velocity is V1. Here velocity is V2. Therefore, what are the coordinates of P in terms of these variables? T1, V1. Here it is T2, V2. T2, V2. Now you join these 2 points with a straight line. By using a straight line. Now you find out the slope of this line PQ. Slope of the line PQ is equal to change in y coordinates divided by change in x coordinates. Change in y coordinates V2 minus V1 divided by change in x coordinates T2 minus T1. What is this V2 minus V1 indicates? Change in velocity divided by time interval. What is this? Change in velocity divided by time interval indicates average acceleration. It indicates average acceleration. Average acceleration. Therefore, that average acceleration, A average is equal to V2 minus V1 divided by T2 minus T1. V2 minus V1, 6 minus 0. T2 minus T1, 4 minus 0. 6 divided by 4, 1.5 meter per second square. Average acceleration, it is the slope of the line PQ. That is slope of velocity time curve indicates average acceleration. Slope of velocity time graph indicates average acceleration. Now you can observe this. If you decrease the time interval, that is, the time interval is now t is equal to 1 second to t is equal to 3 seconds. This time interval. During this time interval, that is in 2 seconds, what happens to these 2 points P and Q? Approach with each other. Those P and Q are reached to this position. It becomes the straight line. Its slope indicates average acceleration during that time interval t is equal to 1 second to t is equal to 3 seconds. Again, if you decrease the time interval t is equal to 1.5 seconds to t is equal to 2.5 seconds, what happens to these 2 points P and Q? Reach it to here. Now, if you join these 2 points with the straight line, the slope of that straight line gives average acceleration during the time interval t is equal to 1.5 seconds to t is equal to 2.5 seconds. That is, as the time interval is decreases, then these 2 points are come close together. If the time, okay, in that manner, if you decrease the time interval, then what happens to those 2 points P and Q? Come close together, and finally there appears to be in contact with each other. At that situation, if you join the 2 points P and Q, it gives a tangent to this curved path. Already the same concept were discussed, similar concept were discussed in case of average velocity and also instantaneous velocity. Similarly, here, if we decrease the time interval and the time interval is tends to 0, then this line P and Q becomes the tangent to this curved path. Remember that. I want to explain that also here with the help of this graph. If we decrease the time interval and if the time interval approaches to 0, I am assuming that time interval is delta t. Delta t is tends to 0. Already we are discussed it. It is 0.00000001 seconds. Nothing but it tends to 0. If the time interval is tends to 0, P and Q appears almost coincides with each other. Points P and Q almost coincides with each other. Coincides. Thus the PQ line becomes the tangent. Then that PQ line becomes the tangent to the curved path. Becomes the tangent to the curved path. Curve. Tangent to the curve. Which curve it is? Velocity time curve. It becomes the tangent to the curve. Now, slope of the tangent indicates what it is? Yes, it is instantaneous acceleration. Slope of the tangent indicates instantaneous acceleration. Why we are called it as instantaneous acceleration? Because it is the acceleration at that particular time interval. At a particular instant of time. It is the acceleration at the particular instant of time. That's why we called it as instantaneous acceleration. Okay. Slope of the tangent indicates instantaneous acceleration. Slope of the tangent indicates instantaneous acceleration. Remember that. Okay, now we want to find out the instantaneous acceleration at t is equal to 2.5 seconds. At t is equal to 2.5 seconds. Instantaneous acceleration of the particle. Instantaneous acceleration of the particle. Instantaneous acceleration of the particle is A is equal to, how we calculate that? At t is equal to 2.5 seconds. I am assuming it is 2.5 seconds. 2.5 seconds. Corresponding to this, you can draw a line onto this curve. At this point, now you can draw a tangent corresponding to that point. You can draw the tangent corresponding to this point, corresponding to this time interval. Assume it is the point A and it is the point B. Now, that instantaneous acceleration becomes slope of the tangent AB, slope of the tangent AB, that is slope of the tangent drawn to the curved point at t is equal to 2.5 seconds. Now, what are the coordinates of A? It is 1.2. Okay, you can assume t is 1.2 seconds, comma, corresponding velocity 0. Now you can draw a line in this manner. What about this? 4.2. That is 4.2 seconds, comma, corresponding to that 4.2 seconds, what is the velocity? 4 meters per second. 4 meters per second. Therefore, slope of the tangent nothing but change in y coordinates, that is 4 minus 0, divided by change in x coordinates, 4.2 minus 1.2. 4.2 minus 1.2. That is 4 divided by 3. 1.33 meter per second square. 1.33 meter per second square. What is this acceleration indicates? Instantaneous acceleration. That is acceleration of a particle at a particular instant of time we are called as instantaneous acceleration. Now another graph, it is also a velocity time graph. Another velocity time graph. Plot a graph in between velocity and time. Velocity is taken along y-axis. It is in meter per second. Time interval t in seconds. Time interval t is in seconds. Now, when we plot the graph in between velocity and time, when the particle is moving along a same straight line, in the previous case, we got it as a curve. Now here, I want to consider it as a straight line. When we plot the graph in between velocity and time for the motion of a particle, it gives a straight line which is passing through the origin. It is passing through the origin. Now it is 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds. Sorry. One meter per second, 2 meter per second, 3 meter per second, 4 meters per second, 4 meters per second, like this. Now you can observe this. in this first 2 seconds, what is the velocity of the particle, or what is the change in velocity of the particle? 1 meter per second minus 0 meter per second. Change in velocity. How much? 1 meter per second. Remember that it is the change in velocity. Now in second 2 seconds, next 2 seconds, what is the change in velocity during this time interval? 2 meter per second minus 1 meter per second. 1 meter per second. Next third 2 seconds during this time interval. What is the change in velocity? 3 minus 2. 1 meter per second. Next 2 seconds, also 1 meter per second. That is, here the particle is having equal changes in velocities in equal intervals of time. Equal changes in velocities in equal intervals of time. That's why we can say that the particle is having uniform acceleration. Particle is moving with uniform acceleration. What is meant by the uniform acceleration? What is meant by the uniform acceleration? If the particle is having equal changes in velocities in equal intervals of time, then the particle is said to be moving with uniform acceleration or constant acceleration. If the particle is having equal changes in velocities, equal changes in velocities in equal intervals of time, then the particle is said to be moving with uniform acceleration. The particle is said to be moving with uniform acceleration. Now, during this time interval, what is the change in velocity? 1 meter per second. Here also 1 meter per second. Here also 1 meter per second. Now find out the average velocity during the time interval t is equal to 2 seconds to t is equal to 8 seconds. Sorry, average acceleration. Find out the average acceleration. Average acceleration during the time interval t is equal to 2 seconds to t is equal to 8 seconds. Average acceleration during the time interval t is equal to 2 seconds to t is equal to 8 seconds. Now, that average acceleration, if velocity time graph is given, to find out the average acceleration, we want to find out the slope of the line. Now, similarly, corresponding to t is equal to 8 seconds and t is equal to 2 seconds, when you draw a line, that line is this one, and here it is P and here it is Q. Therefore, average acceleration nothing but slope of the line PQ. Slope of the line PQ. Slope of the line PQ. It is equal to slope of this line PQ. How we will calculate? Change in y coordinates divided by change in x coordinates. What are the coordinates of P? 2, 1, 2 seconds, 1 meter per second. Coordinates of Q, 8 comma 4. 8 comma 4. Now change in y coordinates. You can assume it as v2. Sorry, it is t2. T2 comma v2. Here it is 2 comma 1. T1 comma v1. P is T1 comma v1. Q is T2 comma v2. Change in y coordinates. v2 minus v1 divided by t2 minus t1. Change in velocity divided by time interval. Then it is equal to 8 minus 1 v2 minus v1, that is 4 minus 1 divided by 8 minus 2, which is equal to 4 divided by 6, 2 divided by 3. Okay, here it is 4 minus 1, nothing but 3. It is 3 by 6, which is equal to 1 by 2, or it is equal to 0.5 meter per second square. Average acceleration, here it is 0.5 meter per second square. Now you can observe another time interval 6 to 8. During this time interval, corresponding change in velocity is 1 meter per second. That is 1 meter per second divided by 2, 0.5 meter per second square. If you consider this time interval, it is also 1 divided by 2, 0.5 meter per second square. That is, here the particle is moving with uniform acceleration or constant acceleration, since in every interval of time that average acceleration is equal to how much? 0.5 meter per second square. Now, we find out the instantaneous acceleration. That is, instantaneous acceleration at t is equal to 6 seconds. At t is equal to 6 seconds. We want to find out the instantaneous acceleration at t is equal to 6 seconds. Corresponding to the 6 seconds, you can put a point at here. With respect to this point, you can draw the tangent. Okay, there is no meaning of drawing the tangent to this line. Again, it becomes a straight line. Okay, now instantaneous acceleration, nothing but slope of the same line, PQ. Because this line is passing through this point. Therefore, instantaneous acceleration, A is equal to slope of the line. Slope of the line. It is the tangent actually. Slope of the line, PQ. What is the slope of the line, PQ? Already we have calculated it as 0.5 meter per second square. That is, acceleration at 6 seconds is equal to how much? 0.5 meter per second square. Acceleration at 8 seconds also 0.5 meter per second square. Instantaneous acceleration at 6 seconds 0.5, at 2 seconds also 0.5 meter per second square. Here, how the particle is moving? It is moving with uniform acceleration. When the particle is moving with uniform acceleration, average acceleration is equal to instantaneous acceleration. Average acceleration is equal to instantaneous acceleration. Remember that. Okay. Now you can observe this graph. If it is y-axis and it is x-axis, it is a straight line passing through the horizon. The standard equation for it is y is equal to mx. y is equal to m into x. Instead of y, what we are observe on this line? V. Instead of y, we are considered it as v is equal to, okay, instead of x, which is exist, time t. Instead of x it is t, instead of y it is v. What is this m indicates? M indicates slope of this line. For a given straight line, slope remains constant. Here also m is constant. Here m indicates a constant acceleration. In our discussion, that m indicates nothing but slope of this line indicates a constant acceleration. M indicates a constant acceleration. Therefore, we can write it as v is equal to a into t. If the particle is moving with constant acceleration, when we plot the graph in between velocity and time, it gives a straight line. Remember that. Okay, thank you.